In order to do question 1, I have to first factorize 10x squared plus 10x minus 2. Now that that's been done, I just need to sketch the roots. So one of them is 2 over 5, and one of them is minus a half. And then I draw my U shape, which is meant to go through them. And I know that it says it's more than 0. So my answers are to the left of minus a half, or when x is more than 2 over 5. Question 2 is about transformations. So whenever we do a transformation, we need to complete the square if it's for a quadratic. So it's easy to visualize the transformations. So if I completed the square, I'd get y equals x plus 4 squared minus 16 minus 7, which is x plus 4 squared minus 23. Now I can easily tell if I compare this one and the other one that it's a translation by the vector. So it's gone 4 to the left and 23 down. You could also say that in words. The turning point is minus 4, minus 23. So it's kind of similar. We want to apply these transformations. So if it stretches by a scale factor of a half in the x direction, I want to rewrite this as y equals 2x minus 1 squared. And then I can expand that and I get 4x squared minus 2x plus 1, which is this answer. Question 4 is testing if we can complete the square for the harder questions. So my first trick is to write it as y equals 2 x squared plus 2x plus 4.5. So if we just complete the square for the inside part, we get x plus 1 squared minus 1 plus 4.5. And at the end, just write your 2. And then again, tidy up. And we get 2 x plus 1 squared minus 2 plus 9, which is plus 7. Okay, so rather than just dividing the first two things by 2, divide the whole thing by 2, complete the square, and then tidy up again and times by 2.
Yeah.
If I was to sketch that, I just know that the minimum point is minus 1, 7. And we've got a U-shaped curve, okay? We need the y-intercept as well. The y-intercept is found when x equals 0. So I get 0 plus 0 plus 9. So that must be 9. You wouldn't be able to tell the transformation for part C unless you expand it and then complete the square again. There's no other way to do it. So if we expand this, we get 2 x squared minus 4x plus 4 plus 4x minus 3, which is 2x squared minus 8x plus 8 plus 4x minus 3, which is 2x squared minus 4x plus 5. Now we complete the square of this. So if we take x squared minus 2x plus 2.5, we get x minus 1 squared minus 1 plus 2.5. And then just put 2's all around. And we end up with 2 x minus 1 squared minus 2 plus 5, which is plus 3. And we can tell that we basically have to compare this and this. So we can see that the y coordinate has moved down by 4. So we can call it a translation by, and then minus 4. So from 7 to 3, it's gone down by 4. And it's gone to, we've got -2 inside the brackets, so it's gone to the right by 2.
Yeah.
So for this question, I've just written x squared, x to the power 4 minus 4x squared minus 5 equals 0. And I've realized that it's a hidden quadratic. So x squared squared minus 4x squared minus 5 equals 0. And I can rewrite that with y's. I solve for y and I get y equals 5, y equals -1. And I square root my answers to get 5, root 5. I can't square root -1, so that's no more solutions there. Okay, so what should we do first if we have to substitute u equals 6x squared plus x in order to solve this hidden quadratic again? So first, let's try and write everything in terms of maybe 6x squared. Yeah. So 6x squared, right? Plus 6x squared times what?
2x.
Good. Plus 6x squared plus x squared plus x minus 2 equals 0. Okay. Happy with that so far? So instead, we know that 6x squared equals to u minus x. So therefore, we get u minus x squared plus u minus x times 2x plus u minus x plus x squared plus x minus 2. Now, if we collect like terms, we get u squared after cancelling plus u minus 2 equals 0. Okay, and this is our easier quadratic, which we found. So if we solve that, we get u plus 2 times by u minus 1 equals 0. So therefore, u equals -2 or u equals 1, and then we can solve that. From there, we have to solve x, right? So 6x squared plus x equals -2. And also 6x squared plus x equals 1. 6x squared plus x plus 2 equals 0. And 6x squared plus x minus 1 equals 0. And we have to solve both of these. So this first quadratic has no solutions. And after using the quadratic formula on my calculator, I get x equals a third and x equals -1/2 as my final answers. Okay, back to Edexcel questions. We have to use inequalities to define R. In other words, the question is saying, work out the equation of the line L and work out the equation of the curve C. We know our coordinate geometry. So the line L is y equals mx plus c. Can you work that out for me? Work out the equation of the line L. Good. So the y-intercept is 25. I just work out the gradient by doing 25 minus by 13 divided by 0 minus by -2. Yeah. Which is equal to 12 over 2, which is equal to 6. So my equation of my line is y equals 6x plus 25. This is the harder bit. We have to do the same thing for the quadratic. Okay? So the equation of the quadratic is in the form y equals bracket, 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 bracket. That's one way. Okay? Yeah? Or in this case, we don't know the roots. We know the turning point. So it has to be in the form y equals bracket, bracket squared plus something. Yeah, you said there's no root, so we can go down two methods. We can do this method, which implies we know the roots, right?
Yeah.
Or the second method, which implies we know the turning point, because that's what the completed the square method. Okay, so let me get rid of this for this question, and we'll see the benefit of that in the other question. So I'd write y equals x plus 2 squared plus 13, because we know the turning point is -2, 13. But there's a twist. That's not all we have to do. We have to put an A here.
Yeah, I remember this.
Yeah. You remember it, just if you're not sure why, we don't know if it's been stretched or not. So you have to put an A. We now work out the A by subbing in a coordinate, which we know. The only coordinate we know is this one again. We sub in 0, 25. So 25 equals A, 0 plus 2 squared plus 13, right? 25 equals 4A plus 13. So A equals 25 minus 13, 12, divided by 4, which is 3. So the equation of the quadratic is y equals 3x plus 2 squared plus 13. And then the region R is just defined as being above. So 3x plus 2 squared plus 13 is below R, which is below 6x plus 25. Okay.
I get it. I remember this question. Yeah.
Similar again. So I'll show you how to make it easy. So first, let's read the information and just plot as much information as we know. It reaches a maximum height of 12 meters. Okay. So this is 12. So the coordinate of this is something, comma, 12. Do you agree? What's the coordinate of this one over here? 0, 0.
Yeah.
And what's the coordinate of this one over here? So we have to look for 40 meters. Okay. So what would the coordinate be?
40, 0, 40,
40, comma 0. Okay.
so that'd be 20, 12.
So yes, exactly. This is 20, comma 12 because it's halfway.
Yeah.
And quadratics are always symmetrical. You learn that in projectiles in mechanics and in pure and quadratics. There's two methods we can take. We can do the completed the square method, which is y equals x minus 20 squared plus 12, and put an A here because we know the time, but let's not do this, okay? So the factorized roots are y equals x plus 0, x minus 40, because we know the roots are 0 and 40. Do you agree?
Yeah.
Okay, and then we have to put an A here. The reason we have to put an A here is because traditionally a quadratic is U-shaped. So this has been transformed in some way. How do you work out the A? By subbing in coordinates. So you could pick coordinates. We have to pick this one. You can pick the others, but you'll find you get 0 equals 0. It won't work. But that's fine. Just try another coordinate. So let's sub in 20, 12. 12 equals A times 20 times 20 minus 40. So we get 12 equals minus 400A. And therefore, A equals minus 3/100. Okay, so our final answer is y equals minus 3/100 x minus 40. If we wanted to, we could have also written y equals a x minus 20 squared plus 12 and worked it out that way. Okay, so we could have subbed in 0, 0. 0 equals a minus 20 squared plus 12. Because from here we know the turning point is 20, 12. Does that make sense? And then when we solve a, we get the same answer, minus 3/100. And then the other version of the answer is y equals minus 3/100 bracket x minus 20 squared plus 12. There's two answers. Okay. Part B says, use your equation to get the greatest horizontal distance off the bar from O. So use your equation to get the greatest horizontal distance when y is equal to 3, the height, right? Y is equal to 3. Yeah. So we just sub y equals 3. So we get 3 equals. So if we times by 100 both sides, we get 300 equals minus 3x times by x minus 40. 300 equals minus 3x squared plus 120x. 3x squared minus 120x plus 300 equals 0. Divide both sides by 3. X squared minus 40x plus 100 equals 0. And then solve this. So the quadratic formula tells us that the answer is x equals 20 plus or minus 10 root 3. So the greatest horizontal distance is 20 plus 10 root 3. And then what would one limitation of the model be if we are doing this model for the trajectory of a rugby ball?
We're assuming every distance doesn't exist.
No air resistance and the fact that we're assuming it's symmetrical. So either of those are fine and they're connected. Okay. Another one very similar. I think there's 2 more questions, so very similar ones. So let's have a go. What should I do if I want to model this one over here?
I don't know.
Same thing, it's the same method. So what do we do first? Label
Wait,
that.
wait. That was a description of my English essay in GCSE.
What are you talking about,
I had
man?
to describe that picture in GCSE English.
Okay, let's and then we'll talk about your English GCSE.
Is that recorded?
Yeah, but it's fine. So we could mark the coordinates of A and B, right? So the height is 5 meters. So what would the coordinate of C be? What would the coordinate of C be? The height is 5, so
5, 0, 0,5.
okay. And the base is 6, so what's the coordinate of A and B?
Minus 3 comma 0 and 3 comma 0.
Good. Okay. So then what method do you want to use? What are the 2 options? 2 forms of a quadratic? Completed the square or factorize. So let's just always use factorize if we can. Okay. So what do we get if we had this factorized? Y equals x plus 3, x minus 3. Because we know that the roots are 3 and minus 3. And we have to put an a here to show that it could have been stretched, or in this case, also moved upside down. So we know that a should be some kind of negative number. Yeah? Okay. So now, if we carry on, we sub in, what do we sub in?
5 comma 0. 0 comma 5.
Yep.
So 5 is
5 equals a,
0 plus 3.
0 plus 3 and 0 minus 3. So therefore a equals
5.
minus
9.
5 divided by 9. Okay.
What?
So the equation is y equals minus 5 over 9,
0.
x plus 3, x minus 3. For this one, we have a height of 4.1 and a width of 2. So basically it's saying that the coach is going to try and squeeze in there, right? So 1.2 minus 1.2. So how would we find this coordinate? Either of these. Let's just focus on this one. How would we find that coordinate? We sub in x equals 1.2 and we find out y, right? So we get y equals minus 5 over 9, 1.2 plus 3, so 4.2, 1.2 minus 3, and then we get an answer of 9.8. So then 9.8 is much, much, much bigger than 4.1. So there is enough space for the coach to enter the tunnel. It could be unsuitable if it's not 100% symmetrical and follows, like you mentioned about 3D, if it follows through consistently through from the start to the end of the tunnel. So maybe something to do with that. Let's do the last question. Can you try this? Find the quadratic. So I just made a mistake typing it into my calculator. Instead of 9.8, it's 4.2, but even then 4.2 is bigger than 4.1. So it can pass under the tunnel, but then it's kind of risky as well. There's only 10 centimeters of room. So again, you have to be careful about the model. So you can just say the quadratic curve only applies to the entrance. It should apply all throughout consistently. We have a line 2x plus y equals 6, and we know that a quadratic touches A and passes through B. So my quadratic would look something like this. Obviously not like that. So it would go, okay. So it doesn't pass through A, it only touches. So that's how my quadratic would look. So there's two methods. I know that A is both my minimum point and also my root. So step one would be to work out A and B. So I'll start with B. B is the point when x equals 0. So if I make x equals 0 in the straight line equation, I get 0 plus y equals 6. So therefore, B is 0, 6. Likewise, A is what is it? If B is my y-intercept, what is A?
Your point.
A is the x-intercept. So I make y0 to solve it.
Yeah.
Yeah. So I take this equation and I get 2x plus 0 equals 6. So x equals 3. So A is my point 3, 0.
I think it's 0.6. It's
Wait,
0.4.
hold on. No, it's not. So to find the quadratic, if we completed the square, we'd get y equals something, x minus 3 squared plus 0.
Yeah.
And if it was factorized, we'd get y equals x minus 3, which is also with the a in front. And so either way, we're going to use y equals x minus 3 squared as our starting point. Put the a there. And then the only other coordinate we have is this 0, 6. So 6 equals a 0 minus 3 squared. So therefore a equals 6 divided by 9, which is 2/3. So our final answer is y equals 2/3 x minus 3 squared.